Good morning, Algebra 1. This is our last live recording. It's not our last live lesson. Our last live lesson is going to be Monday, but I'm not doing a recording for that one because that is going to be bingo. Either be there or be square. Core 1, 8:30, bingo time. You have to be there. Core 2, 9:30, bingo time. You got to be there. Because any lesson you're going to be there for has to be that one. If I've never seen you at a live, that's the one to go to. So please come to the live on Monday for bingo to wrap up our year. Today we're just going to do 4 problems we'll walk through real quick. Hopefully it won't take too long, just to sort of set the stage for what we're going to do on Monday. Now, as a disclaimer, stuff like this is maybe even more difficult than you'll see on bingo. Stuff like this is more difficult than you'll see on bingo. But it's still good to know how to do that stuff, to see what we're doing. Now, it's not adding tons of difficulty, just more steps. So let's get started. So our first one. Remember, when we are solving these equations, we want to make sure we are turning things into factored form once the equation is set equal to 0. So step 1, set equation equal to 0. Step 2, put in factored form. And then step 3 is solve each factor. Set each factor equal to 0 and solve. Set each factor equal to 0 and solve. All right. So here, we've already got it set equal to 0. So then I just have to factor this. So I need numbers that multiply to get to 9. So 3 times 3, or negative 3 times negative 3, or 9 times 1. You're good. And it turns out that I'm pretty sure I did this problem wrong because it can't be factored. So I'm going to change this number to a 10, negative 10, x plus 9. And then if I make it the problem like that, then there is a set of factors that will work. So let's see, I need numbers that multiply to get me 9 and add to get me negative 10. So let's see, I don't quite have it yet, but if I do negative 9 and negative 1, it should work. Now keep in mind, when we're doing bingo, I want to be solving our problems fairly quickly. So you want to keep these tricks up your sleeve. So notice I have a negative sign here and a plus at the end. So since the two numbers have to multiply to get me a positive, either both have to be positive or both negative. And since the middle number is negative, both numbers have to be negative. So I'm going to need the x minus 9 and the x minus 1 as my combinations. Okay, so that's my factored form. Sorry, there's people here trying to distract me. So then I've factored it. Now I have to set each factor equal to 0 and solve. So now I've got x minus 9 equals 0, or x minus 1 equals 0. So that means that x equals 9 or x equals 1. And there's that, and that's my first problem done. I can't tell if it's a different color, so I'm going to change to green. Good. Okay. Number 2. So number 2 might be one of the more difficult ones we're going to do today, but that's okay. So number 2 is not set equal to 0. So number 2, I have quadratic stuff on each side. What a dang mess. This looks terrifying and terrible. Like if I told you in September, like, this is an equation we're going to solve, it probably would not have gone over well. But it's not too bad. Because what we're going to do is we're going to try to put all the stuff on one side of the equation. We're going to set one side equal to 0 and just put all this stuff over to the left. So I'm going to go ahead and I'm going to say way over on the right, I'm going to add x squared. And then I'm going to subtract 32x and I'm going to subtract 37. So what I do to one side, I'm going to do to the other. So over here, I'm going to add an x squared. I'm going to subtract 32x, and I'm going to subtract 37. And there's too many spaces here. Okay, I had to change a previous number because I realized when I got to the end of the problem in the first take that it doesn't work. So I had to change this number to 9 instead of 10. So we're going to continue solving. We're going to subtract the x squared, subtract 32x, and subtract 37 from each side. Sorry, add x squared. So that way we get all the variables, all the stuff on one side, and a 0 on the other. 2x squared, 9 minus 32 is negative 23x, plus 63 equals 0. So now once we factor it, we know that 0 times anything is 0, so once you put it into factored form, we can set each factor equal to 0 to figure out what number is going to make it true. So then we have to think about, all right, the only numbers that multiply to get 2 are 2 and 1. So that's the first part of my parenthesis set. And I need my numbers that multiply to get positive 63. So it either has to be plus plus or it has to be minus minus. And I know it has to be minus minus because two positives aren't going to add to get negative 23. Whatever they have to do, whatever they end up being, have to add to get me negative 23. And since both of these numbers are positive, that's going to make my second ones have to be negative. So, numbers that multiply to get 63 are 1 and 63. I always try those ones last because I feel like with a huge last number, almost you'll know, like if this number is like 106, then it's like, oh, maybe it's the big number. Typically with like a reasonably smallish number like 23, not super small, but I'll probably want a smaller factor than that. Let's see, 1 times 63. 3 times 21 gets 63. And 4, 5, 6, 7, 8, oh, 7. 7 times 9. And again, they're all going to be negative. So, I'm going to start, I always start with my smallest numbers just to see if they work. Because I find that more often than not, the smaller ones, the more reasonable ones tend to work. So I'll try 2x minus 7 and x minus 9. And then I'm going to also end up trying as well. Hold on. I'll try 2x minus 7 and x minus 9. And then I'm also going to try 2x minus 9 and x minus 7. I'll start those two first. So, this is going to equal, let's see, 2x squared. 2x times x is 2x squared. 2x times negative 9. Negative 18x. Negative 7 times x is negative 7x. So that leaves plus 63. Leaves us with negative 25x. Not quite what we're looking for. And then this one here leaves us with 2x squared. I'm just going to copy it from above because I can't possibly type it out again. 2 times 7 is negative 14x. Negative 9 times x is negative 9x. Plus 63 gets us negative 23x. Cool, we did it. 2x squared minus 23x plus 63 is what we're looking for there. So, this is what we're looking for. 2x minus 9 and x minus 7 is equivalent to 2x squared minus 23x plus 63. we gotta solve that equals 0, which means 2x minus 9 equals 0, or x minus 7 equals 0. So 2x equals 9 means, oh, it's an arrow, nice. Gives us x is equal to 9 over 2, or x equals 7. Those are our two solutions, x equals 9 over 2 or x equals 7. Pretty cool, huh? Didn't take that long. Do all this in red and green, actually. All that in green, I'm going to highlight our answers. And if we wanted to, we could check our answers. We could plug them in to see if they actually work. But in the interest of this being our last lesson of the year, I'm gonna pull the I don't feel like it card and just move on. But if you want to trust me that 7 squared plus 63 plus 100 is going to be negative of 7 squared plus 32 times 7 plus 37, we'll just go ahead and just trust our math, because I'm pretty sure it's going to work. Okay, next one, 18x squared minus 9x plus 2. This one, the bigger conflict is that first number has a bunch of different factor pairs, and the last one should only have one. So here's another trick. Well, it's really the same exact trick we used before. Two pairs. 2 times 1 gets me 2. It's got to be 2 and 1. And this negative sign tells me they both have to be a minus number. So I need something x minus 1 and something x minus 2. Factor pairs of 18. Go ahead and copy this and paste it a zillion times. Keep up, Microsoft Word. Let's go. 4, 5, maybe? I don't know how many I did. I made it mad. 6. That's a good number, 6. All right, so now things that multiply to get me 18. Again, I'm going to start with the ones that are smaller. Let's see, 3 and 6. And 3 and 6. Then I could do 2 and 9 and 9 and 2. I'll give you one more little trick in a minute too. 1 and 18. 18 and 1. Okay, here's a trick. If your standard form has no common factors, like here we have an 18, a 9, and a 2. 18 and 9 are both divisible by 3 and 9, and 2 and 18 are both divisible by 2, but there's no number that divides into all 3 of these. Like if they were all even, I could cut them all in half. If they were all multiples of 10, I could chop off a 0. Or if they were all multiples of 3, I could divide them by 3. But if there's no common factors, there will be no common factors in my pairs of expressions. So basically, I can cut off a few of these. I can cut off 3 of them, actually. So I'm going to get rid of this one, because the 6 and the 2 are both even. And if this was the case, when I finish multiplying, these will all be even. It'll be like an even x squared. Well, it'll be 18x squared and 2. But this will actually make the middle number also be even. So I'm going to strike through this one. If I can remember how to do strike through, I think it's... I have no idea. I'm going to mess something up, though. Nope. There we go. Control-Shift-X. I'm going to cross off this one because the 2x and the 2. And I'm going to cross off this one because the 18x and the 2. Because those aren't going to work. And that's just a thing you sort of like, you get used to. Because if that was the case, typically in Algebra 2, you'll probably learn, you could just chop this number down as small as you can get. If they were all even, you could chop them all down by an even factor, and that would just get rid of that. Anyway, I'm going to try this one first. I don't know what's right or not, honestly. I'm just going to try it first. So that one gets me 18 x squared, see, minus 12x minus 3x plus 2. That's minus 15x. That doesn't work. Hope one of these works. I'm not seeing one that works, actually. Yeah, no, I'm not seeing one that works. What did I do wrong? What was I doing when planning this lesson? Whatever. We're gonna go with this time. Okay. 2x minus 1 and 9x minus 2. We'll get 18x squared minus 9x minus 4x plus 2. That gets me negative 13x, and yeah, I messed up this problem too. So I'm really on a roll for our last live session, our last recording. 18x and x, that gets me negative 36, that gets me negative 37x. So none of these work. Okay. Awesome. Good job, Mr. Roboto. A+. Okay. So I'm just gonna, I don't know. Yeah, here's the answer. This expression cannot be factored. So there are no rational solutions. And basically that means the numbers can't be written as a fraction. There are solutions to this equation. They're just not rational solutions. So if I graph this, if I graph this equals y on Desmos, which I guess I'll do, there's nothing better to do. If I graph this, oh, there sure are no solutions. Look at that. There's no zeros. Cool. Yeah. Well, this equation has no solution then. Awesome. And it looks like we're done with that problem then. Woohoo. A+. Sorry, I messed that one up for you. That's the website. That's it for you. Okay. The last one. Let's see if I messed up. Actually, I'm going to pause it and make sure I didn't mess this problem up before I spend like 20 minutes talking about it. Okay? Cool. This problem will work. It'll give us a solution. Don't worry. I know it looks scary. But our first step here is going to be to distribute out the factor form. And then we are going to set equal to 0. It's a funny little emoji face. Before real emojis were a thing, people had to type that into their conversations. And then factor again, and then continue with our setup. Set factors equal to 0 and solve. So 5 steps to go up for the challenge. So distribute out the factored form. We need to put in an equation. So let's see, 4x times 2x is 8x squared. We're in that fun trick right now. Turns to an exponent. Plus, let's see, 3 times 4x is 12x. Plus 6x gets me 18x. Plus 9 equals 8x plus 6. So next step, I'm going to set this equation equal to 0. So I'll have, hold on. So I will have, let's see, 8x squared. Let's see, I'll subtract 8x from both sides, so I'll get 10x. Subtract 6 from both sides, and I'll get 3 equals 0. Then I gotta factor it again. Okay, so this point we're using our tricks really well at this point. Let's see, the last number is a 3, so I gotta have a 3 and a 1 here at the end. Everything's plus, plus, plus all the way across. It's gonna be a plus 3 and a plus 1. So then I need different combinations. Let's see, I'm gonna try 4x and 3 and 2x and 1. Let's see if that works. Let's see, so 4x times 1 is 4x. 3 times 2x is 6x. But, oh, I got 10x. Oh, that worked. That's wonderful. 4, 3, 2, 1. Awesome. I didn't mean to get it first try, but really I could have also done 4 and 2. I could have tried 1 and 8. I could have tried 1 here and 8 here. And those are the 4 I could have tried. This one gets me the closest at 11, but the real answer is 4, 3, 2, 1. And that gets me the same expression. So then I need 4x plus 3 equals 0, and 2x plus 1 equals 0. And then I got, let's see, x equals, let's see, subtract 3, divide by 4. And x equals subtract 1, divide by 2, negative 1 over 2. So here's my two solutions here. So this has been real challenging. All this stuff virtually, all this factoring and all these, just everything. But it's been a real great unit, guys. You've done better than I thought you were going to. It's really been nerve-wracking teaching this. I've never taught this specific stuff to 8th graders before because my kids have never made it far enough in the year. And that says something. Seeing as I've seen you guys for less time than I've ever seen an 8th grade class before. The fact that you've made it this far says a lot. So, it's been great. Hope your lesson today went okay, despite my many mistakes. But hey, that's par for the course for Mr. Robot, ain't it? Just mistakes all over the place. Please show up for bingo on Monday. Don't forget. Please come. I don't want low attendance. It's been a lot of work. It's going to be fun. It'll be an easy form today. Just a couple questions to set you on your way. And then you are just showing up for bingo on Monday and done with your math for the year, okay? Great job, and I'll miss you guys.